Elon Musk is the man who often catches the spotlight for his next-level innovations. He's not only the richest person in the world, but he's also an environment enthusiast. But in today's video, we're not talking about his SpaceX or Tesla's EV motors. This video is all about the Tesla heat pump. Hello and welcome to our channel. In this video, we'll take you through Tesla's heat pump and show you why this is so essential for the future. But before we begin, if you're new to this channel, join us by subscribing and press the bell icon to never miss a video from us. Without further ado, let's start. With its back-to-back launches, Tesla established itself as one of the few prosperous independent automakers and a pioneer in the electric vehicle industry. Notably, it succeeded against the tide of traditional gas automobiles as well. But a heat pump is a completely different and far more intelligent approach. Contrary to their name, heat pumps don't produce heat in the same way as a conventional central heating system. Heat pumps, on the other hand, operate by moving heat energy. The acceleration of sustainable energy, according to Elon Musk, who founded the electric vehicle manufacturer Tesla, was very crucial. He supported the idea by inventing a brand new concept in sustainable transportation. His cars are not only good for the environment, but also offer the finest possible user experience, a true boost in quality of life. It was an idea that altered everything and revolutionized the US auto industry. Elon Musk spends a lot of time considering how Tesla can improve the air, not just inside their cars, but eventually inside our homes and buildings as well. That's why he also considers why Tesla's heat pump is crucial for the future. But before discussing the future, it is important to discuss how conventional heating and cooling systems operate to comprehend what makes heat pumps so efficient. While there are many various types of central heating systems available, both modern and old, they're all function by creating heat through the consumption of fuel. For instance, furnaces ignite burners with the help of their power source, electricity, oil, or natural gas, which heats an internal component known as a heat exchanger. Through ductwork, warm air is blown across the surface and then distributed throughout the house. Boilers use electricity, gas, or oil to heat water until it turns into steam, but the underlying idea is the same regardless of how they operate: use fuel to produce heat energy. Our current heating and cooling methods are ineffective. It's awful for the environment and harmful to us. For instance, home heating and cooling systems annually emit 441 million metric tons of carbon dioxide into the atmosphere, using about 6% of the electricity generated in the United States. Most of that energy is, however, wasted because many people aren't comfortable in their houses, so there must be a change. We often overlook the more necessities of life and how they can also be enhanced by the capabilities of contemporary technology because we spend so much time here thinking about advanced future technology such as electric cars, spaceships, and solar energy inventions that can take us to new places and open up new possibilities. Electric motors produce a lot of heat while in use, especially the traction motor of a vehicle where size and weight restrictions are combined with a requirement for high power output. But the insulation on the motor windings of electric motors soon deteriorates due to overheating. Permanent magnets in the rotor lose their magnetic qualities as they heat up, and another problem is brought by overheating, which leads to a reduction in efficiency. If we want to lower our overall consumption and create a more sustainable society, we should probably target HVAC, commonly known as heating, ventilation, and air conditioning. If you've been following the news lately, you know that energy has emerged as a major global issue. Currently, technology has the potential to revolutionize HVAC in the US, and the heat pump is here. The fundamental idea underlying heat pumps' genius is, moving something requires less energy than creating it from scratch does. If all you need to do is moving a chair from one side of the room to the other, it'll take more time and effort to create the chair from scratch, similar to how less fuel is required to move heat than it requires to produce it. The best way to imagine a heat pump is as a dual swivel air conditioner. The same equipment provides both heating and cooling. On a hot day, the energy from the sun transfers into the air molecules and accelerates their movement. These fast-moving molecules then impact your skin and transfer their energy into your skin and blood vessels. The relative heat of the air is dependent on the amount of energy it contains or the speed at which the molecules in the air are moving. As a result, your body becomes hotter and you begin to sweat. Your body releases moisture that absorbs the heat energy and evaporates to produce a cooling impact. A coil of tubing with these conductive metal fins surrounding it is used for the cooling side of a heat pump, which operates similarly to any other standard air conditioner. Other options exist for heat pumps to conserve energy. Modern heat pumps have variable speed compressors, allowing them to operate at the exact speed required to heat or cool your home. A heat pump doesn't need to run its compressor at full power on mild days, therefore it doesn't. It can alter its running speed so it only expends the energy it needs. The prevalence of the heat pump depends on where you live because the benefits and drawbacks of this technology are going to vary greatly depending on your climate. Tesla's heat pumps are the technology of the future because the world is changing, and heat pumps indeed are the future of technology. Heat pumps are such a clean winter solution that they have already replaced traditional HVAC systems in many nations, including Japan, Sweden, and New Zealand. Sales are rising everywhere too, even in the United States, where the share of heat pump sales for new single-family homes is over 40%. But why will Tesla's heat pump be so demanding in the future? As the nation switches to cleaner means of producing electricity, keep in mind that heat pumps are powered by electricity, an energy source that is 100% pollution-free. Modern heat pumps have variable speed compressors that allow them to run at the exact speed needed to heat or cool the home. On a moderate day, the heat pump doesn't need to run the compressor at full speed, so it can vary the speed at which it runs, using the energy needed to heat or cool the home. We love air conditioning, but it consumes a tremendous amount of energy to do what it does because to have that constant supply of super cold liquid, the mechanical refrigeration system must be kept running. This means that if the air coming out of the coil has less energy than the ambient air in your room, the air flowing in will feel cold. Molecules will be impacting your skin at a lower velocity and will transfer less energy into your body. We use Freon for this process because it boils at a very low temperature below -20 degrees Celsius or -4 Fahrenheit. Even in its evaporated states, Freon is still cold, but it's not cold enough, so how do we cool it down back to its liquid state again? Since heat equals energy, as that refrigerant liquid absorbs energy from the air, it begins to heat up and evaporate. There's no reason why Tesla's heat pump can achieve the same results as they use renewable energy and are up to 3 times more energy efficient than conventional HVAC systems. The quicker we get them installed, the quicker we can reduce carbon emissions from heat pumps. How much of an energy cost savings compared to an electric fan heater or standard electric hot water service are families likely to see as a result of this exciting new technology? Well, this is a very important question. A heat pump uses energy costs of 85% to 90%, which is comparable to the government's predictions. Our calculations show that a typical heat pump using average electricity from the grid would reduce emissions by 25% compared to gas and 35% compared to an electric fan if used instead of exporting your excess rooftop solar output to run a heat pump. No doubt, heat pumps are also good for the environment. Furthermore, the earlier we install heat pumps, the faster we can reduce carbon emissions because heat pumps use clean energy and are up to 3 times more energy efficient than conventional HVAC. Although switching to heat pump technology won't solve all of the world's problems, it'll undoubtedly increase your home's comfort. This is a significant step toward changing our culture and society and creating a sustainable future for all. And here, Tesla and Elon Musk have the potential to inform and excite people about the sustainability of their HVAC systems and the quality of the air they produce. And here we come to the end. Do you also think that new Tesla heat pumps will be a masterstroke from Musk? Does this device have the potential to take us to a sustainable future? Tell us in the comments. To appreciate our efforts, like the video and subscribe to the channel. See you in another exciting video.